Okay, so before we start making the beams, let's turn a few things off so um, we can see what we're doing here. So let me turn the surfaces off. Want to get down to just lines. And I'll zoom in here a little bit so we can see these. So now we have our ribs tracking relatively close to our surface. And we want to turn those into beam elements. So if that's our intersected geometry, it's a curve. And we're going to now thicken it up. So what we want to do is, first of all, have a little bit of control over where it sits with respect to the roof plane. We don't want these to show up in the roof plane, so we'll go ahead and offset them. Let's see which one it is. I think it's this one. Offset a curve in a distance. So we'll go ahead and we'll grab that geometry. And let's see if, I don't know if this already has a default value of 1. So here's the original geometry, here's the new one, kind of a subset that would sit underneath that form if it was still on. And we're going to make it very close. So I'm going to grab a number or just copy this one. And we're going to make this very small. I think I did 0.3. Could be even be closer than that. And it'll move that line very close. We'll turn this line off now because we no longer need it. So that's our new beam coming 0.3 to the what would be the defined surface. And now we want to actually, like I said, thicken this up. So we can do this a variety of ways, but let's look at polycurve, and then thicken. So and I wanted to only do it one side, so I'm not seeing the right one, so I have to thicken and curve. I'm not getting all the choices I should here. Let me think what I got to add to this. Polycurve. I'll do it by, by thicken. Thickening curve. Sorry about this. And I'm not getting the option for both sides. Oh, wait a minute. It does give you a normal. I'm sorry, I probably had the right one right away. It gives us a, no, it doesn't. Oh yeah, it does. It gives us a normal so we can go in a direction and a thickness. All right, so I don't know why this got stuck on all the way over here. So let's take and feed the curve in here. Let's give it a thickness. Copy a number over. We could make it 6 inches, 0.5 feet. And we need a direction, so we need a vector. And I'm not exactly sure what we got here. Let's zoom in a little bit. So the polycurve is on both sides of the line. That's a bit annoying. So let's just compensate for that for now, just so we keep moving through this. I mean, if you can think up a better way to define this, Usually this thickening gives you both sides or one side, but I'm not finding that function. So instead of this being offset by 0.3, we could offset it by 0.5. Well, we're actually going to be offset enough. If I was to show the form, it probably won't show through. I'm going to just leave that for now, just so you realize that the polyline, let me just zoom in here. The polyline we're creating is just extruding up both up and down, and we put it 0.3 away, so there's still some clearance for the form. So if our ribs are actually showing through, we know how we would compensate for that. So we have a thickened curve, and now we want to just make that a surface. So we'll do a surface by patch. Now that's a solid. Let's go ahead and start turning some of this off. Let's go back here and get rid of things we don't need to see. Now we have that thing as a thin 6-inch piece of rib, and it's a surface, and then we can thicken a surface also. And this is where we get the option for both sides on this function. And so we'll plug the surface in, and I think that'll run it right away, and that'll make it a default of 1 foot thick. So we want to actually make a smaller number for that. So we'll go ahead and copy over, and we'll make this 0.2, which would be a couple inches, basically, a little under a couple inches. Now we have our ribs will turn thin, and we want to make it so that it's on both sides, and see what the default is. It's funny how this number thing just jumps over when you click on it again. It's a glitch. And it's true that it's on both sides, so we don't actually have to create the Boolean input for that one. Okay, so actually we've actually created now all the ribs for our structure. The next thing we want to do is start to look at creating these purlins, or the cross members for that. And we're going to use some of the same geometry. What I might do here is let's turn the beams off. I'm going to turn the beams off for a minute. And I want to turn it back on where we have this geometry intersect, because that's just a line. Okay, so that's the geometry that we're going to use now to create the purlins. So we're going to do another curve offset just to get them away from, just to get some control over that. And I'll just repeat using this element again. Actually, I'll grab all of these. I'll grab these two, and I'll do copy and paste, and slide these down. And I'll preview this. I'll turn this one on now. So we're seeing those are just down there. That just gives us a point, it gives us a little control over making sure that where they sit with respect to the beams that we construct. And I can turn off this geometry now because we no longer need it. This is our reference geometry that we're going to divide up in order to create our purlins. So we're going to do a curve pointed segments. I don't know if we still have that up here. No. So let's grab at equal segment lengths. And so the idea here is we're going to stick the curve in. We're going to grab a number. And it did that glitchy thing, so I'll go back over there. And I think I made, for this one, I think I did 6 divisions. That'll give us 5 points. All right, so the default is 10. I'm changing it now to 5 points. 1, 2, 3, 4, 5. And that's 5 times 20 ribs is 100 points. So we have 100 points now. And this is where we start to look at the idea of how we really want to connect rib 1, point 1 with rib 2, point 1 with rib 3.1. We want to make these purlins go all the way across. So this becomes a manipulation of list in order to get our organization oriented the way we want it. I don't have a better way of saying that right now. Let's take a look now at what comes out of our data. I'm going to grab this watch box. I'm going to pull this over. And what we have is we have lists of lists. Each list has 5 points, 0 to 4. So 0 is included as like 1. So 1, 2, 3, 4, 5. And we have 20 lists of those. So each one of these, if I click on one of these, I don't know if it'll show up on the screen, but that'll highlight one of the points in our system. Let's see if we can just back up enough to make sure we can see them all. So there's that point I have highlighted. So if we went through, and you see as we click through this, we'll get every point on each rib. And what we really want to do is be able to connect this point to this point to the next one down. So we need a way of parsing through our list in order to get the elements that we want. And so I've come up with a strategy to do that, and it's maybe not the best way, but it's a way that I could understand as I work through this project for the first time. So I'm going to take this list and flatten it down right away. So instead of having a list of lists, I just have one huge list. So now I have 100 points, and I know if I was to, let's zoom in here a little bit. It's the same thing though. If I grab this point, I get the first one, and I know if I go down to the 5th point, I get the next one in the series. If I go down to, I think it's the 11th point then, nope, the 10th point, I get the next one in the series. So I have to go and step through every other 5 numbers in the list to get all the ones that are coordinated to be that element. So there's a few tools for that. I can take every item out of the list at a certain position. So I'm going to do a list take. It's called list take. Every nth item. So I'm going to plug the list now into that. And I want to grab every 5th item. And so if I go through the list now, I've got every point through that whole list. So let's go ahead now and make a line out of it. So I'm going to do a NURBS curve. By control points. Oh no, by points. I don't need control points. I don't need a degree. All right, so we'll plug the points in, and we now have a NURBS curve through every one of those points. That's great, but we only have one. We only have a list of 20. We only went through we flattened this list out, and we went through each 5 items, and we needed to go through and parse the next element, number 2. We actually need to go through the list 5 times in order to come up with that, each of the lines that we need. So the way we do that is we grab and let me just rotate this around. So this is, you see a static image all the time. It probably helps if you can see through. And this one is missing this point. This is NURBS by control point. So it's not exactly aligned with this because we're really severely trying to pull this one down at this element. So these aren't in perfect alignment. I'm also seeing something I don't like. It switches back over, well, it's got to do that. It switches back over the geometry on the other side, which is fine. Okay, so we've got to deal with the idea of getting all the lines in now. And the way to do that is to actually come up with a list of lists, so we cycle through that offset. The offset being, right now it's taking the 0 item. We want it to take the 1 item, the 2 item, the 3 item, and the 4 item. So the way we do that is I'm going to double click to get a code block. And we're going to go from 0 to 4 5 times, because that's the number of. And if I plug that into a watch list, we get a list of 0, 1, 2, 3, and 4. So every time we go through the list, we're offsetting the one that we select by an increment of 1. So now if I plug this into the offset, we get all 5 of our lines appearing. So let's just take a look at what we've got now. So now we have our geometry. We've got our geometry in both directions. And in some ways, if you think about this, what we actually have is we've divided this off into UV space. So this is kind of like looking into what a node might be that divides things off into panels and points. So let's go ahead now and keep moving forward. I'll actually end this clip now, and we'll go back and we'll go through the idea of thickening these curves up to make the purlins out of them and turn the other curved beams back on again. But we'll do that, like I said, in the next clip.